Hey there, aspiring developers. Today we're diving into a super cool project that's not just practical, but also a fantastic learning journey into the world of React and APIs. We're going to build a currency converter, a tool that lets you easily convert amounts from one currency to another. Imagine you're planning a trip or shopping online from a foreign website. Knowing how much you're spending in your own currency can be incredibly handy, right? That's exactly what our project aims to solve. Our currency converter is a React component that interacts with the exchange rate API to fetch real-time currency conversion rates. It's designed to be highly extensible, meaning you can easily add more currencies as needed. We'll manage states for user inputs, handle the conversion logic, and even implement try-catch blocks for robust error handling to deal with any hiccups that might occur while fetching data from the API or during the conversion process. We've sprinkled the code with comments to help you understand each step of the way. This project is not just about getting the end result. It's about learning how to work with APIs, manage state in React, and handle errors gracefully, skills that are essential for any budding web developer. Now let's dive into the code and start building our very own currency converter. Ready to turn those coding gears in your brain? Let's get started. Embarking on a deep dive into the intricacies of our React currency converter, we begin by understanding the foundational elements that compose our application. The journey starts with importing essential dependencies. React, the cornerstone of our application, enables us to define components with rich functionality and state management. The hooks, useState and useEffect, are pivotal for managing local component state and side effects respectively, allowing our application to respond to user input and external data changes dynamically. Axios, a promise-based HTTP client, simplifies the process of making asynchronous requests to external APIs, crucial for fetching real-time currency conversion rates. The declaration of the currency converter functional component marks the blueprint of our application. This structure leverages the modern React functional component paradigm, emphasizing reusability, simplicity, and the power of hooks for state and effects management. It serves as the container for our application's logic and UI, setting the stage for a user-interactive currency conversion tool. Initializing the component state using the useState hook, we meticulously allocate memory for storing various pieces of information, vital to our application's functionality. This includes the available currencies, the selected currencies for conversion, the amount to be converted, the conversion result, and any error messages. Each piece of state is adeptly managed, ensuring our application remains responsive and up-to-date with the user's interactions and external data. To populate the list of available currencies, useEffect comes into play immediately after the component mounts. It triggers an asynchronous operation to fetch the currency data from an external API. This effect meticulously handles the asynchronous nature of web requests, updating the component state with the fetched data. It exemplifies the seamless integration of external data into React's component lifecycle, enriching our application with a dynamic dataset of currencies. The convert currency function embodies the core functionality of our application, executing the currency conversion process. It orchestrates an asynchronous request to the currency conversion API, leveraging the selected currencies and amount specified by the user. Upon receiving the conversion result, it updates the component state, reflecting the outcome in the UI. This function not only demonstrates asynchronous data handling within React, but also highlights the application's responsiveness to user input, providing immediate feedback on currency conversion requests. An additional useEffect hook is strategically placed to monitor changes in the selected currencies and the amount to be converted. It ensures that any alteration in these inputs by the user triggers a recalculation of the conversion, maintaining the application's reactivity and ensuring the displayed conversion result is always accurate. This pattern showcases the power of React's hooks to effortlessly synchronize the UI with the application state. Rendering the component's UI, we craft an interactive interface that allows users to input the amount to convert, select currencies, and initiate the conversion process. This section bridges the gap between the application's logic and the user, creating a seamless and intuitive experience. The dynamic rendering of conversion results and error messages further enhances the application's interactivity, providing immediate and relevant feedback to the user. Throughout the application, error handling is paramount. By employing try-catch blocks within asynchronous operations, we safeguard the application against unexpected failures. This approach ensures that any issues encountered during API requests or the conversion process are gracefully handled, maintaining the application's reliability and user trust. As we conclude our exploration, it's crucial to reflect on the evolution of handling asynchronous operations in JavaScript. The transition from callback functions to promises represented a significant advancement, offering a more structured and readable approach to managing asynchronous code. Promises introduce a robust framework for handling the eventual completion or failure of asynchronous tasks, simplifying error handling and improving code maintainability. This step-by-step walkthrough of the currency converter application in React not only elucidates the technical workings of each component, but also underscores the thoughtful architecture and modern JavaScript practices that underpin a responsive and user-friendly web application. Through this lens, we gain a deeper appreciation for the elegance and power of React, coupled with the advancements in asynchronous programming, in crafting dynamic and interactive web experiences. As we wrap up our journey through building a currency converter in React, it's important to reflect on how such a component fits into the grand scheme of web application development. This currency converter isn't just a standalone piece, it's a cog in the larger machinery of a web application. Its design and implementation highlight several key principles in software development, including extensibility, reusability, and efficiency, which are crucial for any developer navigating the JavaScript and React ecosystem. Extensibility is a core aspect of this currency converter. The component is designed in a way that new currencies can be easily added to the list without modifying the core logic of the application. This is a testament to writing future-proof code, which is adaptable to changes, such as fluctuations in international markets or expansions in the scope of your application. By leveraging an external API for currency rates, we ensure that our component remains up-to-date and scalable, accommodating a global audience without the need for constant manual updates. Reusability is another hallmark of this project. The currency converter component is built to be dropped into any part of a larger application with minimal adjustments. Whether you're developing an e-commerce platform, a financial dashboard, or a travel application, this currency converter can enhance functionality, providing users with real-time currency conversion without leaving your application. This reusability saves development time and resources, allowing you to focus on other features that require more attention. Efficiency in development is achieved through the use of React and modern JavaScript features like async is await for handling API requests. React's component-based architecture encourages the development of modular, maintainable, and testable code. Furthermore, by utilizing hooks such as useState and useEffect, we manage state and side effects in a declarative manner, making the code more readable and easier to debug. The use of Axios for promise-based HTTP requests simplifies the process of fetching data from external sources, ensuring that our application is both responsive and performant. In the context of development principles and JavaScript technologies, this currency converter exemplifies how understanding and applying these concepts can lead to the creation of robust, user-friendly web applications. As you continue to build and refine your own projects, remember the importance of writing code that is not just functional, but also adaptable, maintainable, and efficient. Thanks for watching, everyone, and don't worry if you missed anything. We've added a link to the source code in the description. If you found this video to be helpful, please like and subscribe for more of the same. Thanks again, and remember, we're always learning. So keep coding, keep exploring, and keep building amazing web applications.